Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with learnbay.co. Happy learning!
Let's start with the operators now. So the operators in Python, so there are different operators. So let's see what all operators we have. The operators we have, first one is arithmetic operator. Okay. Next we have the comparison operator. Next one we have is equality operator. Next one we have is arithmetic, comparison, equality, and then we have logical. Then we have after logical we have binary. Sorry, what is that? Bitwise operator. Okay, and after bitwise we have the assignment operator. Then we have compound assignment operator. Then we have after compound assignment, what is compound assignment? Yeah, membership operator. Okay, and then we have identity operator. Fine. So these all are the different operators we have in Python: arithmetic, comparison, equality, logical, then bitwise, then assignment, compound assignment, membership, and identity operator. The last one is ternary operator, which I will discuss later. Okay, so these all are the different operators we have in Python. Now let's start with the arithmetic operator. Okay, so let's start with the arithmetic operator. Which all arithmetic operators we have in Python? So the arithmetic operators we have is plus, then minus, then multiplication, then single division, which is called the true division. Okay, and it is also called the float division. Okay, then we have floor division. Then we have modulo operator. Then we have exponent operator. Okay, these all are the different operators we have in the Python. Fine, means different arithmetic operators we have in Python. These arithmetic operators are applicable on all number types. Okay, exception you have is modulo operator does not work on the complex numbers. Okay, it does not work on the complex number. So for example, if you want to find the summation, subtraction, multiplication, division, any value in the for the you can say any value, if you want to find any operation you want to do on any number, you can do that. We need to understand here this true division and floor division. Okay, so these all are the two division which we need to understand. Rest all you know. I'll explain the modulo also. Let's see what it does, and these two are important. Okay, so let's see how this true division works. So true division is what? So let's say true division. If you will try to find the true division in the Google, then what is true division? Operator always tries to produce a true floating point result. Okay, so whenever you try to divide a number with another number, then it will always try to give you a floating point value. Okay, after division. Okay, that's why it is also called the float division. Okay, for example, let's say if you have 10/2, this will give you the floating point value, which is 5.0. By default, it is, though you have not taken any floating point value, but it is giving you the result is floating point value. If you will execute 10 by 3, then it will give you 3.33333 and so on till the end. Okay, so this is the it will always give you the floating point value. That's why we say, and it completely divides the value. That's why we say it is a floating point division or the true division. Next, we have the floor division. Okay, so in the floor division, what happens? It always gives you the floor value. Okay, or you can say it always gives you the quotient. Okay, for example, if you are writing 10 /2, what will be the quotient? It will be 5, and it always returns you the integer value. Okay, execute it, the result is 5. Okay, and if you'll be writing 10 /3, then also it will return you 3. Okay, fine, clear. Now, special case will return float value, quotient value, if any one or both numbers are float. Okay, for example, if you are writing print 10.0/3, then it will give you 3.0. It is giving you the floating point value. That is fine. Okay, but still it is giving you the 3 quotient only, right? That's why we say it is a floor value or float. Clear, everyone? Any questions till here? Okay, so this is the floor division. Next, we have the modulo operator. Now, let's see how the modulo operator works. Modulo operator. What is modulo operator? This sign, and this always gives you the remainder. Okay, it will always give you the remainder. For example, if you'll write 10 percentile 3, the remainder is what? 1. Okay, let's say if you will write 10 percentile 4, the remainder is what? 2. Clear? Fine. Okay, similarly, you can use it with the complex number also. For example, you may write 10 plus 20j j percentile 5 minus 2j. Okay, so this will give you the remainder. Yes, fine, execute it. So print, this should be again inside the bracket. Okay, complex number, sorry. Okay, so in this case, as I said, this complex exception modulo operator does not work on the complex number. This will not work, but let's say if you'll do the component exponent, it will do the exponent of these values. Okay, fine, everyone. Clear? Any questions?
Does floor division work on complex values?
Yeah, any value will work on the complex value. So let's say if you will be writing here, instead of this, if you're writing floor division, then it is going to work. You can't take floor of complex number. No, it is not taking. This is taking. Floor division does not take. So let's write that modulo operator and floor division does not work on the complex number. Okay, fine. Anything else, guys? Any question in this arithmetic operators?
No.
Any question? No. Okay, great. So I'll take a break of 2 minutes. I'll be back in 2 minutes. Okay, just give me 2 minutes.
Oh, Abhishek.
Okay, so now let's start with the next operator. So this is the arithmetic operator. Next we have the comparison operator. Now, what is the comparison operator? So the comparison operators we are having are the less than, equal to, greater than, and greater than equal to. These all are the comparison operators. Okay, fine. Now let's see what all things we need to discuss here in the comparison operator. See, so let's say if you are going to compare, first of all, comparison between int and float is possible. Okay, comparison between different data type is not possible. In the different data types, the comparison is possible only between int and float, but in other data types it is not possible. Int and float, and comparison between other data types is not possible. Okay, even comparison between complex to complex is not possible. Okay, fine. Now, so let's see this. For example, let's say if you are writing print 10 less than 20, true. If you're writing 10 less than 10 dot 20, this is also true. Let's say if you are writing print 10 less than 10 plus 20j. First of all, comparison with complex number is not possible at all. But if you are doing complex to complex also, if you're writing 5 plus 5j, this is not possible. And even if you try to compare a integer value, let's say if I'm writing 65 or let's say 66 less than a, okay, this is also not possible. Okay, if you will be executing it, so these three are going to give you the error, but these two are fine. This is true. If you will execute this, not possible. If you will execute this, this is also not possible, not supported between complex and complex. And if you will execute this, this is also not supported between int and str. Clear? Fine, everyone?
In both are str type means that is possible.
No, yes, both. If both are str type, so between similar data type it is possible. For example, let's say if you're writing Python less than Python, okay, so now it is going to compare it and it will give you the true. Okay, so the between the similar data type it is possible. Okay, fine. Now how it is finding it is true. So now here it is doing the let's say if you will write here Python less than this. Okay, so the length of this is higher than this. If you will be executing it, it is giving you true. So how it executes the value, or it compares the value with the ASCII character. So what is the ASCII character of capital P? Print. How you can get the ASCII character? So to get the ASCII equivalent of any character, we have the ORD function, and remember ORD function takes only one character. Okay, takes only one character. Okay, fine. Now let's say if you want to find the ordinal value or the ASCII equivalent of capital P, you may write capital P. Similarly, you may write ORD value of small p. So here you may write small p. This will give you the corresponding ORD value. If you will be executing it, ORD value of capital P is what? 80, and ORD value of small p is 112. So the ASCII value of capital P is less than the ASCII value of small p. That's why it is giving you the true. Clear? Fine. And even if you're writing ON also, in that case also it will be true. Why? Because ASCII value is lesser than this. Clear? Fine, everyone?
Yes, Abhishek.
Okay. Now, similarly, if you will be doing this comparison with the list value. So let's say if you're writing 10, 20, 30 and less than if you're writing 100, 5, 4, if you'll execute it, so this is giving you true. Why? Because the comparison with the first value itself is true. So it will not go and compare the next value. But let's say if here you are writing 1000 and then you are executing, so now it is giving you false. Clear? Let's say here if you are keeping the same 100, but here you are keeping 20 and 5. So in this case also it is false. But here if you keep 50, then it will be true. Okay, fine. So element by element comparison is happening in the sequence side. Clear, guys?
Abhishek, can we get the ASCII value of a string?
No, you cannot get the ASCII value of a string. You have to pass only one single character. Okay.
So, Abhishek, so comparison between a list depends on the first value itself.
First value, if first value are same, then it will go to the second value. If second values, but element by element comparison will happen. First element of this with versus first element of this. Second element of this versus second element of this. It's not like first element of this and then second element of this. It will never happen like that. Okay.
Okay.
Okay. Now the next one we have is the equality operator. So let's see what all equality operator we have. So equality operators are equal to and not equal to. Okay, fine. So if you will see this equal to, so first of all comparison between okay, so equality comparison between different data type is possible. Okay, first point. And next point is, so you can do the equality comparison between different data types. And next point is equality operator compares the values only. Okay, for example, let's say if you are writing print, let's say if I'm writing here, what is the ASCII value of A? ASCII value of A, let me check ASCII value of A here, capital A. Okay, ASCII value of A, it is giving me 65. Let's say if I'm writing print A less than and equal to 65, will it be true or false? True or false? It will be an error. It will be an error. Okay, why? Because you cannot do the comparison between a string and an integer type, right? But let's say if you will be writing here capital A equal to 65. Okay, this will be true. Why? Sorry, this will be false. Why? Because the content on the left hand side and the content on the right hand side are not equal at all. So if you will be executing it, it will give you false. Okay, whereas same thing if you will write here something like this, A is equal to A, this will be true. Why? Because the content are similar, right? So equality operator always compares the values or the content of the operands. Is that clear, guys? So tell me whether this will be true or false. Last one.
False.
It will be false.
False. Why? Because both are A, but there is one extra space here, so it will be false. Okay, fine. So this is what the equality operator. Similarly, now equality operator, wherever equality operator is giving you true, it will be giving you false in the case of not equal operator, and wherever it is giving you false, it will give you true in the case of not equality operator. Okay, clear, guys? Any question? Any question?
No question.
Okay.
So you use Abhishek, one question. So if you use to find that ASCII character, you use one function, right? So that will return an integer, right?
Yes.
Okay.
So for example, let's say if you're writing ORD of 8 is returning me 65. Okay. Now to get the character equivalent of any ASCII value. Okay, the function we have is char, and it will take only a number. Okay, fine. Now, for example, let's say if I'll be writing chr, sorry, this is not char, chr of, let's say if I'm writing 65, it will return me a. Okay, if I'll be writing 112, then it will return me small p. Clear? Fine, everyone.
Yeah.
Yeah, Abhishek.
What is the type of the output, Abhishek? Is it string? Even if we
String.
are
String.
in the first case, ASCII equivalent to character.
This one.
Yeah. So what is
Check
the
the type.
type of this?
Check the type here. You know how to check the type? Integer type.
So when the type is int and the output is 65, why in equality it is not giving a true value?
No. If you are writing equality operator, how it will give you? Tell me how it will be giving you
Fine.
a. Let's say if you will be writing here ORD of
ORD.
a. Now this
Now
will be
it
give you true.
Then true.
Cool. Yeah, fine.
Okay. So this is the equality operator. Now let's apply the let's see the logical operator. Okay. Now the logical operators we have are and, or, and not. Okay. And there is a truth table which we need to follow. So let's see what is that truth table. So and truth table is what? Logical operators. So control it. So a truth table for and. Let's see. Truth table for and. Okay. Now, so if you have true, true and true, then the result will be true. Okay. If you will have true and false, then the result will be false. Okay. If you have false and true, okay, then also the result will be false. And if you have false and false, then also the result will be false. Okay. Now, what can we understand from here? That if any one value is false, then result is false. That's it. Clear? If one value is false, result is false. If one value is false, result is false. If one value is false, both are false, so obviously the result will be false. Okay. Now, same truth table you have for the or also. Truth table of or. Okay. If any one value is true, then the result will be true. Okay. For example, true here, you will be having true here, you will be having true here. Okay. And this will be false. So instead of and, you will be having or. This will also be or. Okay. Fine. So these all are the truth table of and or. Now, truth table of not operator. So just opposite, not of true if you will write, that will give you false, and not of false if you will write, that will give you true. Okay. So this is the truth table of logical operator. Now, why I am writing this truth table of logical operator? So how this logical operator works? So why do we say it is a logical operator? So we say logical operator. So this operator works on the logic. Okay. And logic should always be evaluated as true or false. Logic should always be evaluated as true or false. Okay. For example, let's say if you are writing, so tell me 10 is true or false?
True.
10 is true or false? So if you are writing 10 and true, the result will be what? True or 10. For example, let's forget about 10. Let's say if you are writing true. So if you are writing true and true, then the result will be what?
True.
True. Let's say if you are writing 10 less than 20 and you are writing true, is not equal to true, then what will be the result? What will be the result here?
False.
False. Why? Because this is true and this is false, right? So now this will be evaluated as true and this will be evaluated as false. So now you are getting the result as false. Now, can you observe one thing from this table? Let's say in the case of AND table, we are looking for the false value, right? So how it is giving you the output? So it will always look for the false value. Let's say if the first expression is false, then it will return that value. Here, the first expression itself is false. It is not going and checking the second value. It is directly returning the result. Here also, if the first value is false, it is directly returning in the result. And if first value is not false or first expression is not false, then it will go and check the second value. Here it is checking the second value and second value is false, so it is returning the false. And where if it will not find the any value as false, then it will return the second value. Now what does it mean? So let's say if you have A and B, so it will return A if A is false, else it will return B. Okay, understood? Understood? Let's see what I'm trying to say here. For example, let's say if you are writing empty string and 0, can anyone tell me what will be the result?
False.
Is it? Let's execute it. So it is going to give you the empty result only. Why? Because empty result itself is false, no? So in this case, what I have written, it will return you the value directly. It will not return you false or true. Clear?
Okay.
Yeah.
Fine. So if you have the values, then it will return the values. So first value itself is false. So it will not go and check the second value. So first value itself is false. It has printed the first value. Clear? Let's say if I am writing print 10 and 20, then what will be the result?
10.
10 is true, right?
20.
It has to check for the false value.
Yeah,
False is not there, so it will check the second value. Second value will be returned, right? In this case, it is going to return 20. Okay. Now let's say if I am writing 0 and 0.0, what will be the result?
0.0.
0. Why? Because first value itself is false. So what is the advantage of going and checking the second value? Clear, everyone?
Yes, sir.
Okay. So if you will be executing it, it will be getting 0. Okay. Now, similar to this, you have the OR operator also. So if you will write A or B, so returns A if A is true, else it returns B. So tell me, in this case, what will be the result?
0.
Yes, 0.
0.
0, right? And in the second case?
10.
10. In the third case?
0.0.
0.0. Why? Because first value is not true, so it will go and check the second value, right? Second value is also not true, so it will return the second value. Clear?
Okay.
Fine, everyone. Any question till here?
No.
Okay, so this is the logical operators we have. Now let's come to the bitwise operator. Now what are bitwise operator we have? Bitwise AND, bitwise OR, bitwise XOR, bitwise negation, bitwise left shift, and bitwise right shift. These all are the bitwise operators. Okay, now let's see this bitwise operator, how does it work? So bitwise operators also follow a truth table. Why do we say bitwise operator? Because these all operators work only on bits. Now what all bits you have? You have only 2 bits, 0 and 1. Only 2 bits, where 0 means false and 1 means true. Okay, so you have only 2 bits. And now, so how the bits work? So first of all, these operators works only on integer value. Why? Because so if you have any character, what is ASCII value? ASCII value is whatever keys you have on your keyboard that can be represented into a number, and that number is always an integer value, correct? So everything I have told in the earlier class, that everything eventually converted into the lower level language, and lower level language is what? Binary values. Okay, and binary values is what? Only 0 and 1. So when it is only 0 and 1, everything is converted into 0 and 1. To convert everything into the 0 and 1, we need only the integer value. And how you will get the integer value? So every character which you are typing, that is having a corresponding ASCII value or Unicode value, that will be represented into the binary value. Okay, fine. So these operators always work on the integers. Okay, now when it works on the integers, so all integer values are converted into bits representation, and then bit by bit operation happens. Clear? For example, let's say if you are writing, so first let's see the truth table of bitwise and bitwise OR and bitwise NOR, XOR. So bitwise and truth table. Okay, so first of all we have 1 and 1, so the result will be 1. If you have 1 and 0, then the result will be 0. If you are having 0 and 1, then also the result will be 0. And if you are writing 0 and 0, then the result is 0. So this is bitwise and truth table. Now what is bitwise or truth table? Or, so when two bits are similar, the result will be 1. If any one bit is 1, the result will be 1. Okay, if both the bits are 0, then only result is 0. In the case of bitwise XOR operation, so bitwise XOR truth table, if both the bits are similar, then the result will be 0. If both the bits are dissimilar, then only the result will be 1. This is the bitwise and bitwise OR and bitwise XOR operators and their truth table correspondingly. Clear? Now let's come and perform this operation on the bits. For example, if you are writing 23 and 40, okay, or let's say 400, then what will be the result? How you can get the bitwise operation between them? So what I said, every value will be converted into what? Every value will be converted into a binary equivalent, right? So let's get the binary equivalent of 23. So I'll be writing print bin of 23. What will be the binary equivalent of 23? It is 10111, right? So this is the, you can write here 23 is equal to this value. Okay. Now let's find the binary equivalent of 400. Executed binary equivalent of 400 is this value, correct? So let's write it. 400 is equal to this value, right? Now see, the number of bits are not matching here. So 400 will obviously have a larger number of bits. So if you want to do this operation, the number of bits should match. Now remember, you cannot add the zeros in the end because that will change the value. So you should add the 0 in the beginning to make the same number of digits. Now it is matching. Now you want to do the bitwise AND operation, right? So this is the bitwise AND operation. Okay. This is the bitwise AND operation. So when you want to do the bitwise AND operation, in that case, let's see how it works. So in the case of bitwise AND operation, remember this table. If both the bits are 1, then only the result is 1. Otherwise, the result is 0. So here the result will be 0. This will be 0. This will be 0. This will be 0. Here only it will be 1, and rest all will be 0. So I can say 1, 2, 3, 4. 4 are zeros, then 1, and then 4 zeros, right? So basically, I can write 1 and 4 times 0. Clear? This is the result of bitwise AND operation, isn't it? Those zeros in the beginning you can easily remove. Okay, so zeros in the beginning doesn't have any significance. Now to convert this value into the decimal equivalent, what we can write? We will be writing 0b of 0b of 1 4 times 0. This will give you the decimal equivalent of this binary value, right? So if you'll be executing it, so you are getting 16. Now, are we getting 16 here? So yes, we are getting 16 here. Clear, everyone? Is it clear how this bitwise operator is working?
Yes,
Yes.
Abhishek.
Yes, Abhishek.
Now, the question is where we will be using this bitwise operator. See, as a data scientist, you are not going to use this bitwise operator at all. Why we are learning this? So the learning outcome of here is to learn these concepts. These all are the basic concepts which you should know, because there are, when you go to NumPy also, there you have bitwise operations. Okay, so you should know at least the operation or the concepts which all are the basic concepts. You may face some question in the interview or somewhere else, so at least you should have the knowledge how it works. Okay, that's it. Okay, now let's say if you are going to perform bitwise OR operation. Okay, so this is the bitwise OR sign is this one, bitwise OR. This is bitwise OR. Okay, now so if you want to do the bitwise OR operation, then in that case what you'll be, how you'll be working. So bitwise OR operation, if you want to do, then in that case, if any one bit is 1, then the result is 1, otherwise the result is 0. So here 1 1 1 and this is 0, and then 1 and then 0 0 and then double 1. So basically double 1, then double 0, right, and then 1, then 0, and then triple 1. Okay, this is what the result. Now let's find the binary equivalent, sorry, decimal equivalent of this. So you'll be writing 0b of this value. Execute it. So you are getting 407. Now if I will be writing, let's say, print 23 or 400, are we getting 407? Yes, we are getting 407. Clear, everyone? How you can do the bitwise OR operation. Similarly, let's say how we can do the bitwise OR operation. So in the bitwise OR operation, if both the bits are different, then only result will be 1. If both the bits are similar, then the result will be 0. So here 1, here 1. So basically 1 1, then double 0, and then here also it is similar. So again double 0 and then triple 1. Clear? Now let's execute this. So if you'll be writing print 1 2 4 6 9, 1 2 4 6 9. So let's see this. 0b, double 1, 1 2 3 4, triple 1. Execute this. So 391. So if we will do the bitwise XOR operation between 23 XOR 400, are we getting 391? Yes. So this is how the bitwise AND OR and XOR operators are working. I hope this is clear for everyone.
Yes.
Yes, Abhishek.
Okay. Ramesh, there is no such PDF file, but I'll be sharing these all things. You go ahead and practice it, follow the videos, you have the recording. I don't have any such PDF files or any written notes or something.
Yeah, sure, Abhishek. Okay.
Okay.
Yeah.
Okay. So now this is the bitwise AND OR and XOR operation. Now let's come to the next topic. In this we have bitwise negation operation. This is the bitwise negation operation. Now how this bitwise negation operation works? So this is the tilde sign. This is the tilde sign. Okay. Bitwise negation. Let's say if you're writing bitwise negation of a number, then the result will be minus of number plus 1. This will be the result. Clear? So let's say if you are writing bitwise negation of 10, then can anyone tell me what will be the result here?
Minus 11.
Minus 11. Clear? Fine. Similarly, let's say if you're writing bitwise negation of minus 9, then what will be the result?
10.
8.
Is it 8?
Minus 8.
Right?
Okay,
Minus
yes.
9 plus 1 minus 8, minus 8 into minus 8 is plus 8. So it is 8. Okay. Now let's say if I'll be writing bitwise negation of false, what will be the result?
True.
True.
It will be 1. Okay, minus 1. Clear? 0 plus 1, 1 and minus 1. Fine, everyone? Clear? How you are getting
Yes.
it? Okay. Now Now let's see bitwise left shift and bitwise right shift. We have bitwise left shift, bitwise left shift, which is this sign, and bitwise right shift operator, which is this sign. Okay, these all are the two shift operators, left shift and right shift. Now let's see how does it work. So while doing the left shift, for that, how does it work? So these operators takes two operands. Okay, first one, the number which you want to shift, and second is the number by how many bits you want to shift. Okay, now if you'll be writing it, let's say okay, so bitwise left shift and bitwise right shift. Okay, so in this what happens, let's say if you want to shift a number, let's say I want to shift a number, do let's say I want to shift 230, shift 230 by 5 bits, to 30 by 5 bits towards left hand side. Okay, towards left hand side. Okay, so let's see how it works. So if you want to shift 230, you'll be writing 230 on the left hand side. Then left shift you want to do, you'll be writing this left shift operator. How many bits? 5 bits you want to do, you'll be writing 5 bits here. Okay, now if you'll be executing it, it will be giving you the result. But let's see how does it work. So the first step you need to do, step 1. Okay, convert 230 into binary equivalent. Okay, so the first step, first of all, let's do this. Print bin of 230 is equal to, this is the binary equivalent of 230, right? So let me write here 230 is equal to this value. Okay, now in this step 2, what you are going to do, in this step 2, write the binary equivalent in 32 or 64-bit representation. Okay, for example, why we are writing 32 or 64-bit, that is the default system this one you have, right? So whether it is 32-bit or 64-bit, so accordingly it gets stored in the memory. If it is 32-bit, then 32-bit operating system will be storing any value in the form of 32-bit. If it is 64-bit operating system, then the value will be storing it in the 64-bit information. Okay, so let's say I am taking the smaller one, I'm taking this 32-bit. Okay, so this is how many bits you have? 1, 2, 3, 4, 5, 6, 7, 8. 8 bits we have, right? Now, so this is the 32-bit representation I'm taking. I'll be taking these are the 8 bits. This is the 4 and this is the 4. Now let's write 1, 2, 3, 4. 1, 2, 3, 4. This is the 16 and this is the 24 and this is the 32. Okay. This is the total 32-bit representation of what? 230. Correct. So you can say 230 is equal to this, right? Now you want to do step 3. You want to do left shift by 5 bits, right? So remove 5 zeros from left hand side. Okay, fine. This is the step 3 and add 5 zeros in the right hand side. Okay, so let's do that. I'll be removing 5 zeros here. So let's remove 1, 2, 3, 4 and 5. Okay, so 1, 2, 3, 4 and 5. Now add 5 zeros. 1, 2, 3, 4, 5. This is the again. Now it is a 32-bit representation of the result. Now next thing you need to do here is the step 4 is step 4. Use print 0b and 0b and the resultant bits. Okay, correct. You write it like this. Okay, means you will be writing print 0b and this one, this value. Okay, execute this. You will be getting 7360. It means you will do the 5 bits shifting towards left hand side of 230. Then the result you will be getting is 7360. Is it? So let's execute this. You are getting 7360. Clear, everyone?
Yes, Abhishek, but can you tell me where we actually use this left bit operator and right bit bitwise left shift?
See, these all are done in the internal operations. Okay, so those who are working on, those who are developing kind of high-end softwares or the kind of OS and all, so they work with the bits. We are not going to use them. Even I also have not find any use. I'm into the web development, but I have not find the use of these operators a lot. Okay.
Okay.
Fine, everyone. So this is what we have. Yes.
Abhishek, when we are shifting to the left and we are considering the zeros to be shifted, is it the zeros which are going back? If the zeros at the beginning in the left side would have been 0, 1, 0, would we see it coming back from the right hand side when we are shifting it, or zeros will be added at the end?
So zeros will be added at the end, whether it is getting shifted from left side to right side, whether you do that or whether you remove it and add it here. So manually you will be removing and adding. Internally what happens, who knows? Okay, whether it is rotating in a circle or it is removing and then adding.
Okay.
Who knows about that? Okay.
Okay.
Fine. Now, so what is the, let's say if you want to do the right shift operation. So I'm going to do the same operation with the right shift. So in this case, what will happen now? The bits will be removed from the right hand side and added towards the left hand side. Shift 230 by 5 bits towards right hand side. So let's see how it works. So this thing will remain same. Only right shift operator will be written here. Now this is the convert 230 to binary. This is the representation. This is the binary representation of 32 bits. Now this will be this value, right? So copy and paste it here, and remove 5 bits from the right hand side because it is right shift. So 1, 2, 3, 4 and 5. These all are the 5 bits. Remove it and add 5 zeros in the beginning. So 1, 2, 3, 4 and 5. Okay. Now get the binary equivalent of this. So copy this and paste it here. Okay. Now let's execute it. So this is the 7. So, and if you are executing it here also, you are getting 7. Clear? Now here it will be little right binary equivalent. Remove 5 zeros from right hand side and add 5 zeros in the left hand side. Okay, that's it. Rest all will remain same.
Abhishek, remove 5 zeros from our right hand side or 5 bits from right hand side?
Sorry, 5 bits. there should be 5 bits. 5 bits, there are also 5 bits. And add 5 zeros in the right hand side or add 5 zeros in the left hand side. Clear?
Yes.
Okay.
Fine. This is how this bitwise operator works. I hope it is clear. Let me know if you have any question. Otherwise, we'll go to the next operator. Any question, guys? No. Okay. So now let's come to the sorry, what operator we have? Assignment operator. So what is assignment operator? We have assignment operator is equal to sign. This is single equal to, and this we have already seen where you want to assign. This operator is used for assigning a value to a variable. So for example, let's say if you have any value which you want to assign to a variable, you can write that value on the right hand side and the variable on the left hand side. That variable will be holding the value. For example, if you want to assign a Boolean value, you may print this A, it will give you the true. Okay, so you can assign any value with the assignment operator. We don't have we have nothing to discuss here much, so I'll be just skipping it. So let's come to the compound assignment operator, which is important. So let's say I'm taking 10, so it will be 10 now. Okay, now compound assignment operator. Now let's understand the situation, what exactly we want to do here. So A is 10. Okay, now what we want to do, we want to increment A by 5 and the result I want to assign to A again. Okay, fine. So how does it work? So let's say if you have A is equal to 10 and if you are writing A is equal to A plus 5, right? Then print A. This will be the result. If you will be executing this, then what will happen? In this case, A will become 10 plus 5, which is 15. Okay, 10 plus 5, 15. Now execute it. So you are getting 15 here. Fine. This is how the compound assignment operator works. But this is the you can say the extended version. This same operation, how you can do this same operation, you can do this way. You may write A plus equal to 5. It will do the same operation. If you will write A here, still it will be 15. Clear? Now how does it work? So this is this operation is equivalent to this operation. Okay, fine everyone. So what all compound assignment operator we have? We have plus equal to, we have minus equal to, we have multiplication equal to, then float division equal to, then we have float division equal to, then we have modulo equal to, then we have exponent equal to. These all are the different mathematical operators. Then we have bitwise and equal to, bitwise or equal to, bitwise or equal to, bitwise left shift equal to, bitwise right shift equal to, bitwise, what else we have? Bitwise negation equal to, right? Clear? Any other value? No, rest all values gives you the Boolean value, right? Yes. Okay. So these all are the different compound assignment operator we have. And what does it mean? So if you are writing A plus equal to 10, then A equal to A plus 10. If you are writing A float division equal to 100, then it is A equal to A float division 100. So first it will divide the number, and in this case A should be divided in advance. Okay, remember, if you will not divide A and then you will run this code, it will give you there. Though it is A is defined, let's say if you are writing here X. Okay, X is not defined in our program. It will be giving you the error name X is not defined. Okay, so before using this operator, X should be defined. Remember that. Okay, fine. Now, so this is about the compound assignment operator. Next we have is the membership operator and the identity operator. Membership operator. Now what all membership operator we have? We have in and not in. These all are the two membership operators we have. Now how does it work? So they checks whether this checks whether an element is part of the sequence or mapping type or not. On what all data types it works? It works on string, list, tuple, set, Trojan set, dictionary, bytes, byte array, and range also. I hope. Let's see that. Okay. So it will work on all these data types. For example, let's say if I'm writing P in Python, this will give me the false. Why? Because small p is not available. Okay. Let's say if I'm writing 10, 20, 100, and if I'm writing here 100, this will give you true. Okay. Similarly, it can work on this set also. 10 in, let's say if I'm writing 10, 20, 30, this will work. Let's say if I'm writing print print 1 in 1 colon 100, 2 colon 200, 3 colon 300. If you'll be executing it, this is also it will always check the key. In the case of dictionary, always checks the key. Okay. Now let's say for other data types also you can check. Trojan set, dictionary, bytes, byte arrays, you can check. Let's say range. If you're writing 9 in range 10, so this is giving you true. Okay, so in the range also it is working. So on all these data types it will be working. Instead of in, if you'll be writing not in, then it will be giving you the opposite result. So this is the membership operator. Now next we have identity operator. Now what all identity operators we have? We have is and is not. Okay, let's execute it. So in the case of identity operator, it checks the returns true if ID is same for both the operands, else returns false. Okay. For example, let's say if you're writing 10 is 10, or let's write this way: A is equal to 10, B is equal to 10, and if you're writing print A is B, then this will be true. Why? Because ID is same. If you want to check, print use ID of A, and here also you may use ID of B. Okay, this will be returning you true. Similar ID. Let's say if you're writing X is equal to 1000 and Y is equal to 1000, then in this case, if you're writing print X is Y, then in this case it is going to return you false. Why? If you will check the ID of X and Y, this will be different. Okay, fine. So for 1000 the IDs are different. Clear? So this is operator checks the ID. Remember this difference between identity operator and the equality operator. Equality operator compares the content. If you're writing 10 equal to 10, this will be true. If you're writing 1000, let's say here if you are writing print X equal to Y, this will be true. Why? Because your values are similar, right? Content is similar. But in the case of X is Y, it is going to return you false. Why? Because the IDs are different in the case of this. Now, why the ID is different? So let's understand the object usability concept now. Okay. So object usability concept says that objects should be reused. Objects should be reused in case if it is already existing in the memory. Okay, but for limited values only. Okay, what exactly it is? So object usability concept, let's say if one object is already existing in the memory, so Python does the automatic memory management. So if it will create the object, all the objects in the, let's say if you are creating 100 tens, then 100 tens has to be created in the memory. That is the misuse of the memory. Rather than if you have one object, you can just assign, you can create a different references of it, right? So similarly here also, if you create, let's say if you are using 10 values or 100 values and you are creating 100 references, then only references will be creating the 110 values in the memory. Now what does it mean? So let's say if you are writing, if you have integer values, so integer, in the integer, the values from 0 to 256, they follow the object usability concept. In the string, the values from capital A to capital Z, small a to small z, then 0 to 9 and underscore. They all follow the object usability concept. None follow the object usability concept. Boolean value true and false follow the object usability concept. Rest all object does not follow object reusability concept. Fine. None of the object, and even in the integer also outside of this range, will not follow the object usability concept. This is the reason behind this. So this value is falling outside of this range, so that's why it doesn't follow the object usability concept. Whereas this value is falling inside this range, it follows the object usability concept. Okay. Now the question is, why only for these values, or why only for these limits? So while developing the Python, what Python developer has observed that these values are being used regressively in any program. So how many times you use a number like 1 crore or 9,999? Very limited number of times. But almost all the keys or all the keywords which you are using, A, B, C, D, anything which you are writing, internally they are representing any value between 0 to 128, that is the ASCII character, and you have Unicode character which may be extended to 256. So any value which you are writing or any character which you are typing, that will be coming in this only. So most of the values are represented using this range of values. Okay, that's why they are created immediately while running the Python. So when you start your Python, the memory is allocated for these values. Okay, so when you are writing a is equal to 10, it doesn't mean that you are creating one value, the value is already existing, you are just creating a reference of it. But yes, if you create any value outside of that range, then you create that value. Okay, fine everyone.
Object reusability is -5 to 256.
Yeah, somewhere you will find this range varies from place to place. Somewhere you will find, look for it on the official website. Whatever you will get there, the same thing you can do under, like, you know, make a note of it here. Okay, so if it is -5 to 256, you can find -5 to 256. Let's make it -5 to 256. Actually, that is the original range. Okay, fine everyone. Object usability concept. Why the ID is different in this case? Is it clear?
Yep.
Okay. Now the last one operator is the ternary operator. Now let's see what is the ternary operator. So ternary operator is basically, you might have seen this operator in those who are coming from different background, they might know this. So the syntax of this is expression if condition 1, if condition else, let's say I'll be writing expression 1, else expression 2. Okay, so if condition is true, then this will be the result. If condition is false, then this will be the result. Okay, similarly, let's say if you are writing expression 1, you can do the nesting here. If condition 1, else expression 2, if condition 2, else expression 3, if condition 3. Okay, fine. For example, let's say if you want to find the largest of 3 numbers, okay, a is equal to int input enter first number, okay, b is equal to int input enter second number, c is equal to int input enter third number. Okay, now if you want to print here, you may write a if a is greater than b and a is greater than c also. If a is greater than both the number, then only a will be greater. Else if a is not greater, then b will be the result, right? When if b is greater than c. Why I'm not comparing b with a? Because b with a comparison is already done, and since this is false, that's why we are coming here. Okay, now if this is also false, then we'll be writing else if condition 2, else if this is not required.
LC.
else C, correct? So now execute this. So now let's say if I'll enter 10, then 200, and then 1, so the result will be 290. Okay. Let's say if you're writing 100, then 2, then 3, the result will be 100. Let's say if I'm writing 100, then 200, and then this value, then the result will be last one, 3, 4, 5, 6, 7, 8. Okay, everyone. So this is the ternary operator we have.